Hello everybody. Today we're going to be preparing for our factoring and polynomials test. So one thing I just want to mention, make sure you know your multiple choice strategies, which will be done in a separate video. But make sure you know your multiple choice strategies, as you will be able to utilize them for various different questions. Let's jump right to it. Okay, prove the following identities. To prove an identity, I need to put the left-hand side in standard form, put the right-hand side in standard form, and show that they're the same. So to do that, I basically just need to get rid of all of the parentheses. So to do x plus 2 squared, a very common mistake students make, squared means times itself. So I'm going to write it as x plus 2 times x plus 2. I'm going to bring everything else down. And to do that, to multiply polynomials, I do my box method. So x plus 2, x plus 2, x squared plus 2x plus 2x plus 4. Combine like terms, I get x squared plus 4x plus 4. So I'm basically replacing this with x squared plus 4x plus 4. And then I can distribute that, plus 2x plus 4 minus 8. My right-hand side I can distribute to get rid of those parentheses. Now that all the parentheses are gone, I can combine my like terms. I have 4x and 2x is 6x. Positive 4, and negative 8 is 0, or it just cancels. So I have x squared plus 6x on the left. I have x squared plus 6x on the right. I showed that they're the same. I'm done. So to prove an identity, I need to show the left-hand side and the right-hand side are the same. And to do that, I'm basically just performing operations with polynomials to each side. And whenever you have a binomial squared, make sure you write it out twice and do the box in order to do that multiplication. So 2 is pretty much the same thing. Let's move on to number 3. Dividing polynomials. There are two different methods. There's synthetic division and there's long division. If there's nothing in front of the x, if it's just x plus or x minus, it's definitely easiest to do synthetic division. So for synthetic division, I list my coefficients. Be careful for missing terms. My first power is x to the third. So after x to the third should be x to the second. There is no x to the second, so I have to put a placeholder. So 2 for the x to the third. I have to put a 0 because there's no x to the second. Negative 1, and then negative 2. So again, that 0 I'm putting in because there's a missing term. There's no x squared. So technically there's a 0x squared there, and I need to put that in as a placeholder. Whatever I'm dividing by, the opposite of that goes outside. First number comes down, and then for synthetic division, I multiply, add. 2 times 4 is 8, 0 plus 8 is 8. Multiply, I'm multiplying the bottom and the outside, that's 32, add. Multiply, 31 times 4 is 124, add 122. These are the coefficients of the answer. So the answer, I take the original highest exponent and I decrease it by 1. So this 2 means that the first coefficient is 2, but my exponent becomes x to the second, and I keep on going down by 1. After x to the second is x to the first, then my constant term, then my remainder, and the remainder goes over the divisor. And that's your answer. List your coefficients. Put the opposite of what you're dividing by outside. First number comes down, multiply, add. If there's any missing terms, make sure you put a 0 as a placeholder. Now number 4, I can't do synthetic division since there's a 2 in front, so I have to do long division. For long division, divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Those are your steps for long division. So I have 4x to the third plus 10x squared plus 10x minus 1 divided by 2x minus 3. Divide. I'm dividing the first term by the first term. So I'm dividing 4x to the third by 2x. That's 2x squared. Now I multiply. I'm multiplying the top by the outside. I'm distributing it to both of them. 4x to the third minus 6x squared. Subtract. Now when I just subtract, I need to keep change. There's a lot of space here. Keep change, or distribute the negative. So subtract. I change the subtraction to addition, and I change the sign of everything in the second one. Those cancel. 10 plus 6 is 16x squared. And then I bring down. End of cycle. Time to start a new cycle. Divide. I'm back up to the top. Divide the first term by the first term. 16x squared divided by 2x is 8x. Multiply. 8x times this whole thing out here. 16x squared minus 24x. Subtract. Keep change. You're changing the sign of everything in the second polynomial. Bring down. End of cycle. New cycle, back up to the top. Divide. First term by first term. 34x divided by 2x is 17. Multiply. I'm distributing the 17 to both of those. That's 34x minus 51. Subtract. Keep change. Change the sign of everything in the second polynomial. Negative 1 plus 51 is 50. There's nothing left to bring down, so that's my remainder. And just like synthetic division, the remainder goes over the divisor. And that's it. So synthetic division, I can do it's easier if there's nothing in front of the x. If there is something in front of the x, I have to do long division, divide, multiply, subtract, bring down. Which brings us to factoring. So let's hear our factoring song. Schlansky.com, YouTube. Oh, I lost subscribers. That's unfortunate. Playlists. Algebra 2 songs. And let's go factoring.
People with ADHD save 10 hours studying with this Chrome extension.
I don't care.
By all means.
Factor GCF Trinomial
Yeah. So, factor, let's type this up. Factor GCF dots, trinomials, bridge, grouping, can you factor further with soap cubes? AB, A2, AB, B2. Let's talk about all this. Whenever we're factoring, the first thing we need to look for is a GCF. If there's two terms, it could be dots. 3 terms is a trinomial. It might be bridge. 4 or more is grouping. Cubes is also 2 terms, and the formula for cubes AB, A2, AB, B2, whether it's plus or minus, it's AB, A2, AB, B2. The acronym SOAP, Same sign as the original. Opposite, always positive. Same, opposite, always positive. So those are your little formulas for when you have sum and difference of two cubes. Half the battle is identifying what type of factoring you're doing. The other half is doing it. So, number 5. The first thing we need to look for whenever we're factoring is a GCF. Is there a GCF? Yes. A GCF is a number or a variable that's in every term. 2 goes into both. There's an x in both, so 2x is my GCF. GCF is always one set of parentheses. GCF goes up front. Divide to determine what goes inside. Can I factor further? No. Factor GCF dots. Is there a GCF? No. Dots. Well, dots stands for difference of two squares. Difference means subtraction. Is there subtraction here? Yes. Of two squares means they're both perfect squares. Are they both perfect squares? Yes. If you want a more detailed explanation about what perfect squares are, you can go back to the factoring video. I do it in more detail. Once I recognize its dots, 2 sets of parentheses, plus and minus, square root of each. Square root of 4t squared is 2t. Square root of 25 is 5. Can I factor further? No. 2t plus 5, 2t minus 5 is your answer. Factor GCF dots. Is there a GCF? No. There's 3 terms, so it's a trinomial. So trinomials are always 2 sets of parentheses, always a variable in front for each. First sign comes down. Negative times a positive is a negative. So the first sign comes down. For the second sign, you're multiplying the signs. In this case, a negative and a positive is a negative. We're looking for 2 numbers that multiply to the last number. And then whatever this sign is, either add or subtract to the middle number. So what multiplies to 15? 1 and 15. 2 doesn't go in. 3 and 5. Which of those pairs adds to 8? 3 and 5. Bigger number goes first. If you're having trouble coming up with the numbers that multiply to 15, the little trick in the calculator, you can go to y equals the number that you want them to multiply to. In this case, 15 divided by x. Second graph is your table. And then from there, look at the positive numbers. Those are all the values that multiply to 15. You're looking for the one that adds to 8. So if you're not great with your times tables, this trick is very helpful. Factor GCF dots. Is there a GCF? No. There's 3 terms, so it's a trinomial. Since it's x to the 4th and x squared, instead of x and x, I do x squared. What is going on? What did I press? Since instead of x and x, it's x squared and x squared. Other than that, it's the same. First sign comes down. Negative and a negative is a positive. Multiplies to 9. Subtracts to 8. Bigger number comes first. Can I factor any further? Well, I go back to the top of my song. GCF, no. Dots, I see subtraction. That's a perfect square. That's a perfect square. So dots is always 2 sets of parentheses, plus and minus, square root of each. Square root of x squared is x. Square root of 9 is 3. Now, you might be saying, well, Mr. Schlansky, is the second one dots? X squared is a perfect square. 1's a perfect square. But difference of 2 squares must be a difference. It must be subtraction. This is addition, so it cannot be factored further. So that one just comes down. That's your final answer. And a quick check with factoring. If I multiply all of these, I should end up with my first term. So x times x squared is x to the 4th. If you forgot to bring something down, you could have caught that mistake if you do that little quick check. Factor GCF dots. Is there a GCF? Yes. In fact, you know what? Why don't you try number 9 on your own? So please pause, try number 9 on your own, and then unpause. Okay, now that you tried number 9 on your own, is there a GCF? Yes. 2. Divide by the GCF to determine what goes inside. Can I factor further? Yes. That's dots, difference of 2 squares, 2 sets of parentheses, plus and minus, square root of each, x and x, 5 and 5. My elbow keeps on hitting the trackpad and it's causing some problems here. And don't forget to put the GCF down in front, because right now, x times x is not 2x squared, x times 2 is. We're going to skip ahead to number 13. Factor GCF dots. GCF, no. There's 3 terms, so it's a trinomial. Since there's something in front, it's a tricky trinomial. We need to use our bridge method. So we build a bridge from the first to the last term. Don't forget to pay the toll. We're going to have to do that later. So I write that PT there because it's very common for students to forget that step. So I'm multiplying the first and the last. 2 and 7 is 14. I factor the trinomial normally. Variable goes in front for each. First sign comes down. Negative and a negative is a positive. Multiplies the 14. Subtracts the 5. 7 and 2. Pay the toll. Whatever I multiplied by at the beginning, I divide by at the end. If they divide nicely, divide them. So 2 and 2 divide nicely. So that's going to become y plus 1. If they do not divide nicely, then the denominator comes to the front. Quick check. 2y times y is 2y squared. There's 2 scenarios. Scenario 1 divides nicely. The other one doesn't. Scenario 2, they both reduce. And if you want to practice that more, again, I have a separate video for factoring tricky trinomials. I guess we can go over number 16. So why don't you start number 16 on your own? Try number 16 on your own. This is scenario 2, so it's going to be slightly different at the end. But please pause, try 16 on your own, and then unpause. Okay, now that you tried it on your own, is there a GCF? No. There's 3 terms. There's something in front, so it's a tricky trinomial bridge method. X squared plus x minus 72. I factor it normally. A lot of things multiply to 72. First sign comes down, positive, and a negative is a negative. I guess I'll list it all. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Which of those pairs subtracts to 1? 8 and 9, bigger number goes first. Pay the toll. So this is scenario 2, where neither of them divide nicely, but they both reduce. If they both reduce both of them. I can take a 3 out of the 9 and 6, and it becomes 3 over 2. I can take a 2 out of the 8 and 6 and make it 4 over 3. If you can't do 7th grade reducing of fractions, you can go to your calculator, type in the fraction. So, I don't know, there we go. If I want to reduce 9 over 6, I just hit alpha y equals enter to make my fraction template. 9 over 6, and it reduces it. Alpha y equals enter, 8 over 6. So if you can't do it by hand, you can do it in the calculator. Then the denominators come to the front. 2x plus 3 times 3x minus 4. Quick check, 2x times 3x is 6x squared. Is there a GCF? No. There are 4 terms, so 4 or more terms is grouping. So if it's 4 terms, it's going to always be groups of 2 and 2. I pull out the GCF of the first group. I pull the GCF out of the second group. However, if there's a minus in front of the group, I pull a negative out as well. So since 9 is the GCF of the second group, and there's a minus in between, a negative 9 gets pulled out. When you do that, those should match. If they don't match, either they don't factor or you did something wrong. That's step 1 of grouping. Step 2, combine the coefficients. X squared minus 9 is x squared minus 9. The x plus 3 comes down. Can I factor any further? Often with grouping, you'll be able to do dots. And in this case, yes, I see subtraction. I see 2 perfect squares. So 2 sets of parentheses, plus and minus, square root of each. Square root of x squared is x. Square root of 9 is 3. This x plus 3 comes down. I can do a quick check. X, and x is x to the third. That's my answer. Number 19. Is there a GCF? No. There's 4 or more terms, so again, it's going to be grouping. Now, since it's not 4 terms, it's a little bit trickier to determine how the groups are going to be set up, because for 4 terms, it's always 2 and 2. When it's more than 4, here's what we do. We look at the pattern of the exponents. We're starting with to the 4th. After to the 4th is to the 3rd, so the pattern is going down by 1. So after t to the 3rd should be t to the 2nd, it is. After t to the 2nd should be t to the 1st, it's not. So where the pattern ends, the group ends. And if there's 3 terms in the first group, there's 3 terms in the second group. Now that I have the groups, it's the same procedure. I find the GCF of the first group, t squared. So I divide each of those by t squared. Now there is no GCF in the second group. If there is no GCF in the second group, when we're doing grouping, we pull a 1 out. And since there's a minus in front of the group, I'm pulling a negative 1 out. If you don't pull the negative out, they're not going to match. And if they're not going to match, you can't do step 2. So negative 1, t squared minus 3t plus 18. Those have to match. If your signs are all different, it means that you have to take a negative out. That's step 1 of grouping. Step 2, combine my coefficients. T squared minus 1. I keep the like term, t squared minus 3t minus 18. Can I factor further? Well, yeah, I see dots right here. 2 sets of parentheses, plus and minus, square root of each, t and t, 1 and 1. This, I see a trinomial. 2 sets of parentheses, t and t. First sign comes down, negative and a negative is a positive, multiplies to 18, subtracts to 3, 6 and 3, bigger number goes first. I can do a quick check, t, and t is t to the 4th. That's your answer. I call this substitution trinomial. I see something squared minus 11 something plus 24. It's a trinomial. It just has this ugly thing here instead of a regular variable. So I'm going to substitute a different variable y for that x squared minus 2x. And it's going to become y squared minus 11y plus 24. I'm just replacing this ugly thing with a y. Now I factor the trinomial normally. Y and y, first sign comes down, negative and a positive is a negative, multiplies to 24, a lot of things do, adds to 11, 8 and 3, bigger number goes first. Now I replace back. I'm replacing the y with the x squared minus 2x. So it's x squared minus 2x minus 8, and it's x squared minus 2x minus 3. Can I factor further? I see 2 trinomials, x and x. First sign comes down, negative and a negative is a positive. X and x, first sign comes down, negative and a negative is a positive. Multiplies to 8. Subtracts to 2. 4 and 2, bigger number goes first. multiplies to 3, subtracts 2, 3 and 1, bigger number goes first. Can't factor any further. I'm done. That's substitution trinomials. Am I frozen here? Looks like I'm frozen, so just give me one moment. Okay, is there a GCF? No. What's going on here? Did I freeze already? No. Is there a GCF? No. Now there's two terms. Y to the third is not a perfect square, but it is a perfect cube. 125 is a perfect cube. So it's cubes. So I start by writing the formula. AB, A2, AB, B2. So your signs, same, opposite, always positive. First sign is the same, second sign is opposite of that, third sign is always positive. To find A and B, I'm taking the cubed root of each. The cubed root of y cubed is y, the cubed root of 125 is 5. So y cubed minus 125 equals A minus B is y minus 5. A squared is y squared. AB means A times B, which is 5 times y, which is 5y. B squared is 5 squared, which is 25. You might say, Mr. Schlansky, can I factor this trinomial further? When you do cubes, it will always be the case that you will not be able to factor the trinomial further, because there are no numbers that multiply to 25 and add to 5. Reducing rational expressions. You need to factor and then cancel common factors. So it's like two separate factoring problems. This is one of the applications of factoring. There are many, many, many applications of factoring. On top, there's a GCF. On bottom, it's dots. Now that I factored, I cancel common factors. I'm left on top with 2. I'm left on bottom with x minus 3. The only twist that comes up in this lesson, if you had let's just say you had 2x minus 3 over, and I think the next example is like this, but I'm not going to go over it now. If you had something like this, because it's a binomial written backwards with a minus sign, it cancels, but it cancels to -1. So the answer in that case would be -2 over 3 plus x. Again, this isn't the problem that we're going over right now, but that is a little twist. If you have a binomial written backwards with a minus sign, they cancel, but they cancel to -1. So that will come up in number 24, but there's still a couple more problems for me to go over, and I'm running out of time. All right, number 25. N squared equals 3n plus 18. Polynomial equation. Mr. N squared, he wants to party. Before he can party, all of his friends have to come over. Are all of his friends over at his house now? No. So he needs to subtract 3n and subtract 18 from both sides. Step 1 in a polynomial equation is to bring everything to one side. Party time. What do they want to do at the party? Bubbles. Step 2 is to factor. Now, it's not going to always be a trinomial. We just went over tons of types of factoring. You need to be familiar with all the types. It could be GCF, it could be dots, trinomials, tricky trinomials, grouping, it could be anything. First sign comes down, negative and a negative is a positive, multiplies to 18, subtracts to 3, 6 and 3. Finally, we set each factor equal to 0. I set n minus 6 equal to 0. I set n plus 3 equal to 0. n is -3, and n is 6. That's it. So whenever you have a polynomial equation, x squared or higher, number 26 is an x to the third. Same procedure, everything to one side, factor, set each factor equal to 0. And finally, number 27, x squared plus y squared equals 10, x equals y minus 4. A system. Step 1, I need to have a variable by itself in at least one equation. I have x by itself. So I'm going to substitute y minus 4 in for x. So y minus 4 squared plus y squared equals 10. Now we need to do the algebra. We said earlier at the beginning of this review video, whenever you have a binomial squared, y minus 4 squared means y minus 4 times y minus 4. And to do that, we have to do the box. So now I can replace that with y squared minus 8y plus 16 plus y squared equals 10. And just erase that. My trackpad is being a little temperamental. Now I combine like terms. Y squared and y squared is 2y squared. Mr. Y squared, he wants to party. All of his friends have to come over. And once all of his friends come over, it's party time. And at their party, they party with bubbles, which mathematically means factor. First thing we look for when we're factoring is a GCF. There is a GCF. If you have an integer GCF, you can just divide it away and it's gone. Factor it further, it's a trinomial. 2 sets of parentheses, y and y. First sign comes down, negative and the positive is a negative, multiplies to 3, adds to 4. The only thing that multiplies to 3 is 3 and 1. Set each factor equal to 0. I get y equals 3, and I get y equals 1. Now I'm not done. A system has x values and y values, so now to find my corresponding x values, I'm going to substitute into one of the originals. The bottom one is definitely easier. X equals y minus 4. So I get x equals 3 minus 4, x equals 1 minus 4, x equals negative 1, x equals negative 3. And to write my answer, it's always the x-coordinate, comma, the y-coordinate. And then here, the x-coordinate, comma, the y-coordinate. So, if you can do everything we did on this review video, you should be set for your test. Make sure you also know your multiple choice strategies. There's going to be like 5 questions you can get correct based on those. Practice, and practice, and practice. See ya.